Welcome back, guys. I'd like to start with a question. True or false? This statement is false. If you're saying what statement, I'm talking about that statement, the white statement on your screen that says this statement is false. Is it true or false? Well, if it's true, then by its meaning, it has to be false, right? Because the statement itself says that it's false. If it's true and it says it's false, then it must be false. Well, that can't be. So let's think about the other possibility. Well, then it must be false, right? Well, if it's false and it says it's false, then it has to be true. Ruh-roh, we're in trouble. This is called a paradox. A paradox is just a sentence that is neither true nor false according to its meaning. A paradox is a sentence that is inherently contradictory. On the other hand, a proposition is a sentence that is either true or false. Now, remember what it is we're doing here. We're learning to think critically, and we are learning about deductive reasoning. This is material from section 1.1, which is about propositions and connectives. And specifically, we're going to talk about propositions and paradoxes. 1.1 is the section in a transition to advanced mathematics. I've got an image of the 8th edition there on the screen. I'm actually using the 6th edition to come up with these notes. Yeah, so that's the plan. Now, just to sort of bring this in context, we're talking about deductive reasoning. We're talking about how to prove things. So usually the way this will work is we're going to start with some axioms or assumptions or things that we know to be true. And then we're going to unravel all of the logical implications of those facts to come up with a truth and to come up with another truth and to come up with another truth. And as we do that and we create this sort of fabric of truths, we are basically creating a mosaic of this beautiful mathematical structure. That's deductive reasoning. Now, a statement like this, where you're saying, if this is true, then this is true, or if P, then Q, that's called a conditional. I'll also call them an implication. If P, then Q, or if P is true, then Q is true. Now, the only way that that will even make sense is if P or Q, P or Q, or P and Q, if those letters represent what are called propositions, they have to be something, they have to be statements that are either true or false. Otherwise, if P then Q doesn't make any sense. We can't start with paradoxes and say, if this paradox is true, then this paradox is true, because you can't even talk about whether a paradox is true or not. So it's really important that we understand the difference between a proposition and a paradox. So that's what this is about. We're going to learn more about how to prove an implication starting in lesson 1.2. But for right now, we're just learning about propositions and paradoxes. We're going to define the terms and determine whether a given sentence is a proposition, a paradox, or neither. We're going to do this by example. So let's look at our first example. In general, elephants are afraid of mice. Now, I personally, before I looked it up, or actually before somebody else told me that this is true, did not know whether or not elephants are afraid of mice. But it is either true or false. Since the sentence is either true or false, it's a proposition. Now, it turns out to be true in general. I actually asked a young person to give me a statement that was either true or false, and he told me that elephants are afraid of mice, and I trust him. Here's another example. X squared is greater than 10. Is that a statement that is either true or false? Is it a statement that is inherently contradictory, or is it neither? X squared is greater than 10. Well, it's not inherently contradictory. X squared could be greater than 10, or it might not be greater than 10. It really depends on what X is, right? The truth value of this mathematical sentence depends on what the value of the variable X is referring to. Since there's an X in it, it's ambiguous. And that means it isn't true or false, and it isn't inherently contradictory. We just need more information. So this is a sentence that is neither a paradox nor a proposition. Now, if you're saying to yourself, what is a complete mathematical sentence? How could you even tell that that was a mathematical sentence? Every equation and equality is a complete mathematical sentence. So if I see X squared equals 10, or X squared is less than 10, or X squared is greater than 10, all three of those are complete mathematical sentences. Here's my tip. If you can read it out loud and the result is a sentence, it counts. So X squared is equal to 10. Like you could write that out in words, you would put a period at the end, and that would be a sentence. So this is a complete mathematical sentence. You're saying, okay, well, what isn't? A mathematical expression is not a mathematical sentence. Now, if X is a number, X squared minus 2X plus 9 is some other number. We get that number by squaring x and then multiplying it by -2 and then adding it to the x squared and then adding a 9 to that. But that's like a noun. X squared minus 2x plus 9, it's a number. It's like 17. If I just said 17, I said, what about 17? If I just said purse, what about the purse? I said glass of water, what about the glass of water? Hoop earring, just what about the hoop earring? This doesn't really say anything. It just refers to a noun. So that is a mathematical expression. It's not a mathematical sentence. We need that relationship, the equal sign or less than sign or greater than sign or greater than or equal to. We need that something is related to something else in order to have a complete mathematical sentence. Let's look at another example. Proposition, paradox, or neither. 3 squared is greater than 10. Or 9 is greater than 10. Well, 9 is clearly not greater than 10, so it's false. Since it is either true or false, since it's false, it has to be a proposition. It's clearly false. So look what we did here. Compare this to the last example. We had x squared is greater than 10, which was ambiguous. It was neither. But when we gave you a value for x and we plugged in x equals 3, now this statement was clearly false, and so it became a proposition. So we got rid of the ambiguity by making it more specific. Okay, let's look at another one. Oh dear. Oh dear. Proposition, paradox, or neither. Is it true or false? Oh dear. Oh dear. It's an exclamation. Since it's an exclamation, it is neither true nor false. It's not inherently contradictory. Here's another one. Oh dear. Also an exclamation. It's like, oh dear, I guess. If you're like hunting or something, and you're traveling down the road and then you see a deer on the side of the road, you might say, oh dear. That is neither a paradox nor a proposition. Here's another one. Christopher Columbus wore a black t-shirt at least once. Now, if you're saying to yourself, I can't even look that up. Like, how on earth would I even know if Christopher Columbus wore a black t-shirt at least once? That's beside the point. We don't actually need to know whether the statement is true or false in order to decide whether it's a proposition, a paradox, or neither. We just need to know if the statement is either true or false. We just need to know that first part. Like, if it's one of those, if it's either true or false, then it's a proposition. So I don't know whether Christopher Columbus wore a black t-shirt at least once. But I know that during his lifetime, he either wore a black t-shirt once or he didn't. So it has to be one of those. So that means that this is a proposition. It has to be one, even though I don't know which one, and I'll never know. Okay, here's another one. He wore a black t-shirt at least once. Again, that's ambiguous. I don't know who he is referring to. This is not like English class. I'm not going to say that he refers back to Christopher from the last slide. It's just like, he? Who's he? Since I don't know who he is, this statement is neither true nor false. It depends who he is referring to. Okay, here's another one. Hey, how's it going? Is it a statement that's either true or false? Is it inherently contradictory, or is it neither? That's a question. And if it's a question, it's neither. How about this? This one's a little complicated. It's got 2 parts to it. It's got an and statement here. We're going to talk more about and statements in the next video. That says there are at least 3 propositions in these examples, and this sentence is not one of them. Now, it's an and statement. So in order for an and statement to be true, the first part has to be true and the second part has to be true. If one of those is not true, then the whole thing is false. But if it's true or false, then it's a proposition. Okay, so we're keeping all of that in mind. The easiest way to dissect the truth value, to interpret this and decide whether it's true or false, which is called coming up with the truth value of this sentence, is to look at the parts and to think through what this would mean if it were true and if it were false. We're going to go through case by case like we did last time. Okay, if the sentence is true, both of them have to be true. So the first part of the sentence, there are at least 3 propositions in these examples. If you go back through the slides, you'll see that there were at least 3 propositions in the previous slide. So the first part is true. We're good on that. So the truth value of this sentence depends entirely on the second part of the sentence. The part that says this sentence is not one of them, or this sentence is not a proposition, that is determining whether or not the whole sentence is true or false, because we already know that the first part is true. Does that make sense? I hope it makes sense. Okay, so if we say that the sentence is true, and we know that the first part is true, then the second part would also have to be true. So if the sentence is true, and the second part is true, remember the second part of the sentence says that this sentence is not a proposition. But if the sentence is not a proposition, it can't be true. So that's not going to happen. This sentence can't possibly be true. Okay, let's think about the other case. The sentence is false. If the sentence is false. If the sentence is false, then either the first part of the sentence or the second part of the sentence must be false. Since we already know that the first part of the sentence is true, that means the second part must be false. Now, the second part of the sentence says this sentence is not a proposition. If it's false, then that would mean the sentence is a proposition. And if the sentence is a proposition and it's false, like that's okay, because propositions can be true or false. So there's no inconsistency here. If the sentence is false, then the second part would have to be false. And that would be fine because it would be a proposition. That would be consistent with the meaning of the second part of the sentence. Since we've gone through all of that and the only possibility is that this sentence is false, it has a truth value of false, and therefore it is a proposition. Now that's an example that you might want to think through a little bit more. You might even want to argue with me about it. And that's great. I would hope that you would, because I love that you would be thinking for yourself. I want you to think critically about these examples. Okay, another example. There are at least 3 propositions in these examples, or this sentence is not one of them. Now this is an or statement. For an or statement to be true, only one of these has to be true. If this is true or that is true, only one is true, and then the whole thing gets to be true. Well, since the first part of this thing is true, the first part of the sentence is true, that means the whole sentence is true. And if the whole sentence is true, that means it's a proposition. Make sure you agree. Pause it if you don't. Pause it and think about it if you don't. Okay. Here's another one. Philemon is a wonderful person. Is this true or false? Inherently contradictory or neither? It's subjective. Philemon's my stepdad's name. I think he's a wonderful person. But since it is subjective, it has no well-defined truth value. It's an opinion, and an opinion may be either true or false. It may vary from person to person. Since it's an opinion that varies from person to person, it is neither a proposition nor a paradox. Okay, so next time we're going to talk about and statements and or statements, just like those last few examples, just a few examples back, were and statements and or statements. We're going to talk about those in more detail, and we will briefly touch on truth tables, and we'll talk about logical connectives. Those are ways that we represent these and statements and or statements. We're going to talk about a conjunction, which is related to and statements, a disjunction, which is related to or statements, and negation, which is just like the opposite of something. But we'll do all of that next time. Now, before we go, let's just summarize. What did we learn? A proposition is a sentence that is either true or false. And a paradox is a sentence that is neither true or false. Due to its meaning, it's inherently contradictory. And finally, it is possible for a sentence to be neither a paradox nor a proposition. And that would include, examples of that would include questions, exclamations, sentences that depend on the values of unknown variables, pronouns, or something that states an opinion. All of those are sentences that would be neither. Those sentences are ambiguous. All right, that's it for this lesson. I will see you next time, and we'll talk more about and or statements.